Yeah, so hello. And well, today I had an idea. We have all heard about how DeepSeek and other models just copied from OpenAI and other models and made their own models perfect, but at a low cost. So I was like, yeah, we are also learning about AI ML. We are also using some, numbers as a data sets and some features. So we have used n numbers and n features. Mostly our features uh, have been three for the past, I don't know, 10 days. And sometimes the n becomes a million, sometimes it becomes thousand. So I'm like, okay, we are demonstrating or sort of simulating how we can train on a data, and the data we are creating is something like random. All right, but what if we could get some real data so that we can get an idea of how AI models are really trained? So I just asked this GPT, like, DeepSeek copied from other models, AI models, to create their own models at a low cost. So can we do the same for learning purposes? And how can I do that? And I've also given it something like I have lots of local models. So I mostly play with local models and I'm still installing certain local models. So yeah, it's not a big deal. Okay, let's move it. Yeah. So let's open up a terminal and mostly I use Olama and I thought, why not just make a video on how I use Olama. And well, I have integrated my Olama project into multiple different projects because AI can be integrated into anything like stocks to let's say PPT to let's say pipelines, like anything. This Olama, I've used it because I can't get a, API for free. Well, there are certain ways like Open Router and all to get API for free, but it's like sometimes it expires, sometimes it doesn't work, sometimes it works, so it's very unstable. So I thought, why not just use some local AI models? And local AI models are not bad. Like, let me show you. If I run Olama and something like a very you know low parameter model, like something like 394 MB, so it will be loaded quite quickly. Olama, run, and Quen. Okay, I am not getting. Yeah. So you don't get a tab completion over here. You just have to either type it out or you can just say Olama and then you will get something like, okay, let me run a model first and I'll show you another way to use Olama. So if I say hi, it gives me a response quite quickly because, uh, well, it is a very small model, like very small. It's like 394 MBs and it can be used, but not for development purposes. But then Gamma or Gemma 2B parameter model can be used for development purposes. Like I made an AI, well, that's for another video, but I made an AI pipeline, sort of AI agentic pipeline, which sort of makes program. So it made a snake game for me. All right. So if I say, can you make a snake game for me in, let's say, HTML? Since it's very small model, it can sometimes get what you are saying. Sometimes it doesn't. Sometimes it works. Sometimes it doesn't. You see, it's making a paragraph. It's not making a game. In the HTML, it's saying this is a snake game and welcome to the game, blah 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 blah. And there's no script. So how is this a game? So it is because this has well very low parameters as well as low size, so it can run very well. Just let me say exit and we'll exit it. All right. So we'll use Gemma 2 for now because it's fast and it has some context to what we are talking about. So another way to run any model is to just say Olama. And the first thing you get is chat with models. Now don't press enter because it'll directly take you to Gemma 2B. But if you want to select, then you can press, left arrow key. After that, you get recommended models. And in more, you can see how many models you have and you can select it from here. All right. So we'll select Gemma 2B and it's loading. It's loading. And if I say, Can you make a snake game in HTML? And let's see what it does. Because it has made a perfect game. Not perfect at a one go, but it was like, first, just think about it. Second, think of the cons, like pros and cons of this, whatever you were planning. And third, execute it. So first was planning, second was review, third was execute. And the third execution part was, done using Gemma models, but 4B. So large model takes time. But you see, this model understood what we were saying and it started creating a canvas. And this is a canvas where our script will run. And it has started creating script. And we see some variable X and Y, which is, for snake, food, which is for 200, 200. So it is, plotting snake and food at a canvas. So it's working, isn't it? So let's cancel it right now. So we understood how we can use our models and how we can, open it up locally, and it'll work fast because I don't have a very powerful PC. My PC is as powerful as general PCs out there. So it's like Intel i3 7th gen, like very old. All right, 16 GB RAM, which is not a big deal because everyone has 16 GB RAM if you're using Windows. But if you're using Linux, you have a more buffer space because Linux doesn't use much of a RAM. So see, I was running a LLM in 6 GB that was getting used. So this is the benefit of using Linux. First of all, there is no bloatware. Now, second of all, since I thought, why not use these models to train a model that's very specific? Like, let's say we train a model on commands like ls. So it'll know what ls does. It'll have the full context of what ls does, full context about cat and how you can use it, and something like less, or cat only to read it, but something like others like make directory and something like that, and other Linux commands, so that I can make an agentic sort of AI model that can understand what commands to run, where, and how, in which conditions, and everything about it. So I thought, why not just take some, really good instructions from some models like we have already and make our own local model so that we have actually experienced how to make a actual model. Like we have, used local training data sets, or not local but random training data sets just for simulation part. But I really want to know, how can we really train a local model? We know about GD, we know about stochastic GD, which is SGD. We know about something like batch GD. So we'll see how we can do that. So let's see what it does. All right. So it says short answer, yes, but not in a way people casually say copying model, because what you can do legally and practically is knowledge distillation. Like you give it a prompt, you take an instruction, and you fine tune it, our model or your model, and not copying weights or stealing architecture. So let's break it down clearly. What companies like DeepSeek usually do is, when people say DeepSeek copied the model, it's misleading. They likely used combinations of public dataset plus synthetic dataset, distillation from stronger models like GPT at that point of time, and RLHF, which is or preference tuning. I don't know what this means, but we'll know in, I don't know, future or right now. Depends. Now, custom architecture plus training tricks. They did not literally copy the weights from model like OpenAI model or Anthropic model. That would be impossible because first of all, weights is very closed, and second of all, it's illegal. What you can do, which is legit and useful for learning, is, since you said you have many local models that I've shown you, you're actually in a perfect position to experiment. So I will. Now the knowledge distillation part, it's telling me how to, use knowledge distillation for training. That is most important. So this is closest thing to learning from, another AI model. Idea is to use a strong model, which is sort of teacher, let's say Gemma 4B or Llama 3, like whatever, we'll see. And train a smaller model, which is for student to mimic. And we'll make a very dumb model, which I think will have basic idea about commands, basic greeting etiquettes, and that's it. That's it. So that will be our training data. We'll see. Pipeline will look something like we have a prompt, we have a teacher model, we have an output, and the teacher model also saves the prompt and output that it's giving, it's getting and giving both. So it's getting a prompt from our side, it's saving that. It is giving out the output, it is saving that as well. And on that same data set that we have saved, we can train a smaller model on this. So we are not copying the weights, but we are copying the behavior of it. Now there is self-instruct or synthetic data generation. So like we can generate our own data sets. Like I asked something like explain Docker simply. And the output we got was Docker is something that we can, blah, blah, blah. So it stores thousands of these prompts and outputs. And on that, we can fine tune our model, but we don't have a model. That's another question. Like if we start to train model from base up, it will first of all have to take lots of compute. Second of all, has to get a context of what ABC itself is. What are these characters, magic characters that we are using in a specific way? So yeah. And then thirdly, it can understand what the context of like a natural language processor or NLP, something like that. So it'll understand what we are saying, what is the context of what we are saying, and so on. And it says this is how open models improved. Now multi-model ensemble. What is this? It is advanced, and since you have multiple local models, which is sorry, one for coding, second for like let's say reasoning, and third for summarization, fourth for just text generation at a very fast pace. We can combine their output and train one unified model. So fine tuning something like LoRa and QLoRa, tools like transformers, PEFT, Axolot, and Unsloth, which is very fast for local setups. So train something like base model, which is Gemma, Mistral, Llama, and your data set. Fine tune models. What you cannot do is extract weights from proprietary models, reverse engineer the IP APIs, and claim copied output as original training data without transformation. Practical setup for you, which is for me, is based on your workflow. Since you are already working with Olama plus local infra, step by step would be pick a teacher and a student. So teacher would be something like 7B parameter model, which I guess 7B we have a lava, but it's a vision model. So something like Gamma, E4B, or even Quen 3.5. Both would work. Yeah. Gamma has, now approx like 9.6 GB. So it's fairly big model. It'll work. And smaller student model is something like 2B or 3B, which is, let's say Gamma 2B or something like, yeah, Quen 0.5B. So Quen can at least understand what we are saying, isn't it? And it's 351 MBs. Now generate data set, which is like prompt teacher and save it like a JSON format. Data set would be like instructions and output, fine tune using LoRa, and test by comparing students versus teachers. Now example idea that fits your project. Since you are building AI pipelines, build your own mini GPT specialized for coding agents. Feed your past prompts, logs from your system, successful outputs, and train a small fast model like Gemma 2B. The result would be like faster than your large models, but customized to your own style, like my own style. Oh, so reality check. What massive companies, spend millions on is massive data sets, first of all, and that too latest, correct? And massive data sets, GPU clusters that they use to train on, and the data stability. Like it shouldn't fluctuate too much, otherwise, well, fluctuation has a problem. So what we can still achieve locally is surprisingly powerful specialized models and Well, I have lots of questions right now. So let's ask some. Now, I'd like to see how our training data set in JSON file will look like. Like, got something like instructions would be say hello, and it'll say, hello, how can I help you today? If I say greet in a friendly way, it'll give us output, write basic HTML page and all that. So this is basic Python, this is a basic HTML page, and explain for loop and while loop. So we got a minimal beginner friendly data set, and I think I will tell it to use Google Colab because my compute and network is, well, probably not very fast. So, and instead of, yeah, see, that was my question. So if I would do something like instructions and output, so it is, not how actually any AI model will respond. They would respond this way where we have a message and inside that we have either role and inside that content. So we do something like messages dot content, and you know we get this content and we print it out. That's what we do. So this is how a training model should be. Exactly. Now this looks more like how a training data set should be. Basic Linux command you'll use, well, not for me, but for dataset. Okay, so should we use JSON or JSON-L? Like, what is the difference? What is the difference? Should I use Colab for this demonstration or just or no installation steps? And this is the fifth thing it said, like example training, ultra simple using Python. So if using transformer plus PEFT, which we don't have any idea about, we can use something like from dataset import load dataset. And this is some sort of library. And we are saying dataset and we are loading dataset that is JSON. And this is a file that we might have created in future. And then we are printing the dataset for now. We are not doing anything. My important tip that you'll thank me later. Let's see. Start with 50 to 200 examples, not with 10 or not with 10,000. Keep output clean. Bad data is equals to bad model. So be consistent. Be consistent. Don't mix styles like hey bro and greeting users. Like this is very casual and this is very formal. Now pick one tone. Okay. So mini experiment you should try. Since you're already working with local models, so uh, create data sets like your real prompts. We'll do that later on if you want to. But first of all, let's get an idea of how this whole damn thing works and your best output. So train a small model, and pro tip is this is powerful, add variations. Yeah. Now, JSON versus JSON, that was our question. So the real difference is JSON is very single structure file, which is like this. So what is JSON? JSONL, JSON L, JSONL. Pros is that it is very easy to read. JSON is very easy to read, good for small data sets and a standard format. Cons is like the entire file must load into memory. Yeah. Slow for large data sets, harder to append immediately. So JSONL is like JSON line, which is recommended. So we have an instruction, we have output, instruction, output. Each line is equals to one JSON object, and pro would be streamline line bit by bit. Now give me answers. Should I use local or Google Colab? So use JSNL always, because even if your data set is small now, you'll scale later. Yeah, we'll see that. So option one is Google Colab, best for learning demo. So we'll probably use it because we have a free GPU sometimes, and it has a zero setup, works instantly, easy to experiment. Session reset, so that if we do anything wrong, we can just delete that session. That's what I like about Google Colab. In local, you first of all use your space first of all. Second of all, if something happens that you don't know about, because yeah, there are certain things we just have to follow blindly just to learn. So it can be risky. Option two would be full control and all that, blah blah blah, but slower if no GPU. We don't have any GPU, and setup is required. So use Colab for once. Understand training flow and validate a data set, and then move to local. So yeah, so we'll use Colab. That's what we did most of the times, isn't it? And second thing I'll say, this one is to give me a data set like this. Give me valid data set for training. So it has already said us that modern ones support this sort of well data set structure. So we'll only use this only. All right, let's do that. So we are using chat style JSNL format. So JSON line JSNL format. So we have created JSON also. So I thought it was just JSON, but for configuration JSON. But I think I have to ask it. But C for what? C for stands. We were using JSON for configuration of waybar and all hyperlinks and all. So I thought it should be config, but since I'm seeing different variations in JSON and their extensions, so I think there is some difference to it. So chat style like JSONL format is, which is what most modern fine tuning pipelines use, expect. So below is a clean and valid ready to use dataset with greetings and all that, ready to paste. It is 1 2 3 4 5 6. Let's copy that. We want something more. We want something more. So let's make a directory called, no, yeah, make a directory. So I am a bit confused right now. And instead of Olama, we'll use train model, and we'll go inside that, and we'll start creating data.jsnl and then data.jsnl, right? If it's very small, let's make it big. I hope it's visible now. We'll paste it, and we see it's nearly 20, including gaps. Let's remove all these gaps, not required. So only 16 lines. We have to also validate it. So let's see how do we validate it first, and then we add on to it. So we have created it, and it says do something like this. Okay, so I think it's mostly validated. Like this is what we expected. In message, we have role and content, and another role or content. That's what we expected. Yeah, nicely done. Start giving me more data set till I say stop. Will it follow this instruction? Let's see. Let's open up our, folder where we are stored. So this is another batch, dataset batch 2. And now I think this is a little bit bigger than the earlier one. So let's try making it nearly about 500 to 600 lines so that we have at least enough context to give to our models while we are training. So dataset creation is the most important part, and we are just using it for model, a very low end model which we are just learning about. So we'll use datasets that the GPT gives us, but therefore big companies use data science engineer because they can extract data and the values and make it in such a format that AI can easily read it. We are using AI to give us this, but sometimes it works, sometimes it doesn't. Sometimes people don't use these many lines. They'll say explain get, not in one line, just explain get. Or sometimes we will just write something like get. So yeah, data is the important part. Till we are doing this, let's also initialize a Git repo over here. Why? Well, it's important. Why is it important? Because we'll be storing data sets somewhere more secure. Not secure, but yeah, somewhere safe. Yes. I use Linux, and well, I am mostly experimenting with Linux most of the times. These are my repos. If you want, check it out. I'll create a new repo and we'll name it exactly the same as this one, which is train model. Also, I'll do something like, well, open up VS Code, because when I push something to GitHub, my terminal is not set for that. Like it asks for authentication and tokens, yeah, which I already have, but well, I don't think I'll use it except for personal when I'm not recording. Right now, we'll use this to do most of our GitHub things. And this is code OSS. So if you think this looks well different, because it is different, this is open source code. Uh, let's go to a browser and refresh it. Not right now. How about now? Yeah. So we got readme.md. Why didn't we get JSON data JSON? Because to get that, you have to add it. So before adding it, let's first of all edit it perfectly so that we at least have a bit more data. Let's add this batch 4. Let's get a batch 5. I'll probably cut this portion because, it's wasting most of the time. I'm just setting up my environment. So I think this much data set is enough. It's not exactly 500 line because there are like multiple spaces, but I think this is enough just for, getting an idea of how this whole thing works. So we'll quit it and well, we will first of all add everything so that, we can directly fetch our content in a collab. Git commit. And we have data set. And finally git push. Yeah. Now if we refresh repo, yeah, so we got data.jsnl. Let's copy this link so that we can, git clone it. Let's create a new. Why is it taking so much time? And I'm also installing some more, models. I sort of became a model maniac. Just connect. And let's get a terminal. Yeah, so it got connected. Let's see if our terminal, yeah, so we have a terminal. Let's check out by typing ls. We have a sample data. This is not our data, right? So if we do something like, get everything inside sample data. Well, there are multiple numerical datas and some more. So we have certain data, but we won't use that data for now. We'll use our own data. So we'll say git clone and our link to the app. Okay. Let's do ls. So we have a train model. That is our sample model. We'll remove that. And if we do ls now, okay, so we got our train model. So we first of all add a text that, do a git clone for this. Git clone. And this is a command. So we'll say run this on start up. As soon as it starts, we'll run this command. Yeah, this is done. Run this on startup and let's push it forward. Forwards, not forwards. And now if we, do something with our train model, yeah, we got message and everything that we did. ls, or let's do tree. Do we have tree? Okay, tree is not there. ls train model. I can't press Control Shift C because it'll open up the console. So we have to use mouse. So I'll give it a context. So I am in collab. I got my data set ready. And I'll say, let's start with instructions and code on how to train our own model. Well, I'm noting something that my spelling mistakes have reduced. I hope it gets more reduced for now. It's good. Practice makes a man perfect. So it says we'll use LoRa, which is lightweight fine-tuning model. We'll use Hugging Face plus PEFT. I don't know what PEFT means. A small model, which is fast plus works on collab. Okay. So it says install dependencies like transformer, dataset, PEFT, accelerator, and bit standby. This is our step 0. This is our step 1, where we'll load our dataset. So we'll start doing it side by side. Okay, let's remove the vertical tabs. And this is what we are familiar with. All right, let's paste it and run it. Okay. So it's now, I hope, installed. We'll code another thing, that is to load our data set. So we'll say load your data set in a comment, and then we'll just copy paste this and it'll print our data set that has been loaded. Control enter. And it gave us something like, this is not what I expected. I thought we would see something like JSNL, but now this directly gives us the data set and the features, which is the messages, and number of rows, which is 180. All right, nicely done. Now step 2 is choose a base model, something that is small and usable. You can later switch to Mistral Gamma. In step 2, I don't see anything. Oh, I see something. Yeah. Pi 2. Well, how about Quen 0.5? How about that? Good for collab. But since it suggests something like that, we'll use it. If it creates problem, we know which model to use. Light Quen 0.5 is like so lightweight that even I got embarrassed while using it. But it's so blazing fast. Well, it should be blazing fast. Think of it like as a probability machine that throws out the word according to the probability of what's next, and that's what we are seeing actually. So since it has a lower data set, so the probability, the denominator decreases. So similar to that. I don't know if that's what exactly happens, but I hope that's what happens, because then it would be, so crazy about it. Good. Step three, it says, format data set, which is very important. So we'll define a format. Okay, let's start typing so that we get an idea of what we are doing. So all these things, well, nothing more complicated, nothing much complicated, not more. So we have a, data set library. We imported load data set, and from that we loaded the JSON file, and this is a path to that JSON file. And finally, we printed the data set, which is same variable. All right, that's what we did. And now we are starting to format it. So this is where the training starts for both of us, for me, so that I can learn, and for AI model that it can learn. But I am learning how to train a AI model, and AI model is learning what it's getting trained on. Let's not go into the next example. And inside message example, you'll say messages. And after that, we have text. What is this? String. Text is a string, an empty string. And we are saying for message in message, for message in messages. And it's giving me suggestions, but no, I will type it out by hand so that we can learn. Because from, day one, we were learning more about theory. We were so inclined on it, so that we forgot that we came to make some real changes. Now we are checking that if message has a role that is user, we'll do something. Else, if it is assistant, that is the case, the else case, we'll do something else. So if message and inside role is equals to user, we'll do what? We'll say text plus equals to, so whatever the text string is there that we have declared, which is for now nothing, we'll format it in such a way that we say user and, well, the message, and inside that the content. Okay, and then just for the formatting, we give it a new line, and we are saying else. Else is what? Oh, sorry, that's why. Oh shit, what's happening to me? Else text plus equals to format, and this is assistant, and we'll say same thing, message, content. Since it's same, why are we doing this? Just for the sake of assistant and user? Well, I don't know. Or help us. All right, since it's telling us to do this. Content. So I see something that is not right. Oh, content. Yep. And yeah, for formatting purposes, well, let's give it a new line. And this is it. And after else, and from the for loop, we'll just return the text. Return the text. That is the variable text. And we used these curly brackets. Let's use them. Now it says data set is equals to, and we are saying whatever the data set train is, we are mapping that to format chat. We have a data set over here, and we are saying, change that data set from that to something like dataset train, and then map according to format chat. I don't have much of an idea what we are doing right now. Let's do that. Where is this train string? Is it inside our dataset or something else? Like, what is this? Format chat. So this was our step 3. Let's run each of these. So first one, well, it ran. Second one, we'll say model name. The third one, yep, it also ran. 180 line. So it has mapped for 100%. All of the examples. Now step 4 is load tokenizer. So we'll load some sort of tokenizer and a model, which is phi3 in this case, phi2. Yeah. So this is our step 4. We'll comment it out. We'll start writing the code. That is this. Not bad, not bad. So we'll say from transformers library, we'll import. Why not import everything? Well, because it will make our program bulky, bulkier than it already is. Tokenizer, auto tokenizer, auto model for casual LM. I think there is a more possibility of making mistake over here than anywhere else. The names, what are these names? And I'm not getting any suggestions for that. Okay, so for is wrong. It's capital for. Casual LM. Auto model for casual LM. Okay. Now we'll say something like tokenizer, which is a variable. We'll get a value of from auto tokenizer and dot from pre-trained Microsoft Dalio GPT medium. That's what we are getting. Model is auto model for casual LLM from pre-trained. So this is the suggestion that we are getting from Google or Gemini. Let's use what the GPT is suggesting for now. Pre-trained. Oh, TRAINED. Pre-trained, and we already have the model name as a variable above in step 2, I guess. Model name. See? And then we'll say tokenizer dot pad the token that is equals to tokenizer dot EOS. What is EOS? I don't know. I don't have any idea. Let's first do it practically so that we can later on learn about what we did. If we don't do it, we'll actually forget what we are doing. Model for casual LM. Not from, but from pre-trained. And whatever the model name is, exactly. Oh, there are other things as well. So let's press enter over here and give it a few more parameters like load in 4-bit, load in 4-bit, which is true. Why not leave some spaces? We are making compact. Device map is auto. Device map is auto. Okay. So this is a step 4. I don't think there's any error. There shouldn't be. There is. So instead of checking for what the error is, because we don't know if it's our error or GPT's error. Let's directly copy and paste it. This code was already prone to errors. Yeah, so we made a mistake. I don't know where, I don't know why, but we made a mistake. Mostly in the names or something like that. What is it doing? What? We are going to Hugging Face and utils, and yes, oh, the secret HF token doesn't exist, so it'll take some time. We have a config.json. We have tokenizer config.json. We have taken tokenizer.json. We have added tokens.json, and see, this is why I don't use, locally to train model, because 6 GBs, it would take eternity to get installed, because I was installing what? Yeah, this about 2.2 GB, and it took a while. Let's start with this full mystery. Let's close it. We got a Pi 3 mini, and this is what we already got, something like embed text. And over here as well, we got an error, which is not good. The errors like this. Step 5, we have step 6, we have step 7 as well. Step 8, step 9. So we'll say we got an error in step 4 itself. And this was not our error because we didn't do anything stupid. This itself is acting sus. So I think this keyboard is not there. How about we comment it out? Till pad token ID. It doesn't have pad token ID, so something related to this. So let's just copy this arrow and, well, give it to a GPT. I don't know what this is. Why is it? Copy. In step 4, isn't it? In step 4, we got error. So solve it before we proceed to step 5. And let it work for now. So yeah, I am back. And well, we got an error in our 4th step. So it says, yeah, this is very common collab issue. So your error is like actually telling us what's wrong. The problem is we have 5 for casual LM in it. Got an unexpected keyword that is local in 4-bit, meaning that this model does not support local in 4-bit directly. On your transformer plus bits and bytes combo isn't handling it correctly. So fix 2. Two clean options. All right. So option 1 is recommended for now. That is simplest. Remove the 4-bit loading completely. Well, I did that and it changed nothing. Let's do that again. Try running it and it'll change probably nothing. This will work immediately. Well, it doesn't work immediately. Slightly more RAM usage, but fine. Option 2, if you really want 4-bit, use proper quantization config, which is this. So let's use a different code which looks different. Let's try running it. Oh, damn. Nice. This is known quirk with fighting and is easy to fix once you know what's happening. So it says py config object has no attribute of whatever this is, a pad token ID. So meaning the model ID doesn't define a pad token ID. So but training pipeline expects one. So fix that is clean plus reliable. Well, how about just changing the model? Okay, let's see what it does. It says you need to manually set the pad ID token after loading the tokenizer model. So it says this is the correct final fix. Use this. Okay, let's use this. Fix one, set pad token. Fix two, that is set pad token ID in config and dispatch. Sorry, disable the cache, not dispatch. Let's see. Well, it again gave us an error. I hate it. Sanity check. Let's check the sanity so that it doesn't mess with our sanity. Sanity check also gave us an error. That is this. Let's go. Well, real root issue. Well, I was obviously hitting this GPT style, is sometimes irritating. This error happens during model loading, so setting pad token ID doesn't help. Neo transformer version expects pad token ID in config, but this config doesn't include it. So loading fails before model even is created. Clean fix that works. Replace step 4 with this. I don't know what this is, but let's replace it for now. And let's try running it. Why this works? Well, it's working. It's working because it does what? Load configs manually, fixes the missing field, pass corrected config into the model, so model never sees the invalid config, and it's all of a sudden it's working. So let's do what? We'll copy this, we'll create a text, we'll do this, we'll paste it. Yep. And then sanity check this. It should be running well. Yep, sanity check is running. Sanity, PHECK, sanity check. And what was this whole thing? This was our fourth step, no? So we'll say this was a fourth step. That is, where are you? Yeah. So let's say this is a fourth step. Oh shit. I just want enter. Fourth step is ready. Now we should step to step 5. That is apply LoRa. This is the magic. Okay, we'll see what the magic stores. And I think we should type it out. So we'll say from PEFT import LRA config. Oh shit. Cong. No, config. And we'll say get PEFT model. Okay, now LoRa config is equals to LORA conf. Yep. And we'll say something like R is equals to 8 with no space. Why no space? We want to keep it compact. LoRa modules. No, first of all, alpha. Alpha. Hey. Not 32 but 16. Why? No idea. Target modules. MODULES is equals to QPROJ PROJ and VPROJ. Does anything make sense for now? Well, nothing. But it'll start to click once we get a hang of it. What we are doing actually. Drop out is equals to 0.05. Bias is none. Well, just saying the string none doesn't make it none. Let's see. Task type is casual LM. Correct spellings? I hope so. And then we'll do model, not models. We'll do get, PEF, and model. And we'll pass model and LoRa config as the attributes inside the function. And we'll say model.print trainable and parameters print trainable parameters. I hope no spelling mistakes, and it'll give us an error. Why? No idea. Load dropout over here. Oh shit, it was not load, it was LoRa. LoRa. Now what? Is it good? Is it fine? Oh. I don't think this is my mistake. This is, I guess, this one's mistake. So let's copy it, paste it. Oh no, that was my mistake. Damn. What sort of mistake am I making? I had no idea. What was I doing wrong? Shit. And I don't want to spend my time debugging my Python. So we are doing in step 5 what? We are applying the LoRa, that is the magic. We are using importing library PEFT, and from there we are taking LoRa config and get PEFT models. We are taking the LoRa config and we are passing the attributes, that is R is equals to 8, alpha is equals to 16, modules are QPROJ and VPROJ, seems like project. LoRa dropout is 0.05, then bias is none, task type is casual LM, we have model, that is get PEFT models and model LoRa config. And then we have model print trainable parameters. And this is running, so we will start with step 6, that is to tokenize the dataset that we have. All right, we'll tokenize the dataset, but not 3 format. We'll define the tokenize and the example. We'll return, return tokenizer and example text, exactly what it's telling me, but let's do it by our own hands. Truncation, that is true. I hope no spelling mistake. Truncation, true. A comma is required. And then padding is for max length. Then max length is 512. Okay. Then we'll map according to tokenize. We'll map the dataset according to tokenize. That's what we are doing at the last line. Tokenize the dataset. That is equal to dataset and mapping it to tokenize. And it says bashed is equals to true, but not right now. We are not making bashed is equal to true. So we'll just do this and that's it. Let's run it. I hope no errors this time. So no error, and all of these 180 datasets got mapped according to this tokenize example. And now training. This is not how we expected. Like what we have been training on is like, I think we are learning GD, SGD, and all those, batch GD and all those things. We are not actually making some training progress or something like that. I hoped to make some training progress, but we don't. I was disappointed. Transformers, import, training arguments. Trainer and nothing else. And then we have training arguments, that is from training arguments. We are passing what? Passing output directory. That is okay. So we are outputting to a directory called output in content. Output. And I say per device train batch size. Yep. So per device train and batch size is 2, not 1, but 2. per device train batch size. So we are, I guess, training it in batches, but we didn't do over here batch is equals to true or batching is equals to true, whatever. And we are not implementing everything by our own selves. That is not what I expected. But yeah, just for the learning sake, this is exactly how it should go. Logging steps is 10. Oh, so comma can make mistakes. And that's why I think we might have gotten errors previous times as well. Because of commas. And I'm very careless with commas. Learning rate. So see, we are seeing certain things like steps and learning rate and FP16, FP8. We have seen this while learning about this machine learning or not. But now we are using it to actually train our own model, and that is important. Our learning rate, see how low it is. It's in 10 to the power minus 4. That is good. That is good. Multiplied by 2, that is 20 to the power minus 4. Nicely done. Why learning rate is low? Because, well, our data set is high. How high can it be? Like the range of a learning rate, how high can we make it so that it doesn't burst out? It can also be fast. You might have to see that. Okay, so training arguments is done. Now we'll create a trainer. That is actually equal to trainer, or not this. Trainer, yep. And we will pass the arguments of model is equals to our model. That is by 2. Arguments is, training arguments. Training arguments. And train data set. For tokenized data set is this. Then we'll finally call it as trainer.train and it'll start. This is not how I hoped it will go. All right, no errors, I hope. Now it's getting saved. So there was a difference between, well, two files it had, and a conflicting one that too. So yeah, I had to do this. It's taking time because I think this is the training. All right, so training takes time, but I should at least see some outputs, no? How much is getting lost? How much is, which loop are we in? Epoch is only 3, so only 3 epochs, but well, learning rate is low, so it will be time consuming. Our step 8 would be, let's start with a step 8 till this step 7 is getting processed. That is training. So step 8 would be to save a model. So let's say we have created a model of our own. How about saving it? So we'll say what? We'll say model dot save and pre-trained. That is content fine-tuned model. Fine-tuned model. Then we'll have tokenizer. Not save pre-trained. Why are we doing this? We are saving the model and the tokenizer. Okay. What will be the format of it? I don't know. Let's see. After opening up the terminal. Content. CMT. Yeah. fine-tuned, T-U-N-E-D, tuned model. So we are saving it by the same name, I guess. Or is it the directory? Its name. But it's a tokenizer and another one is model. So let's see. From here, File Explorer. Or should we use our terminal? Well, let's see the output. It is empty. Output is empty right now. Okay. Content and file tune model. Okay, so nothing happening over there as well. Train model, it has some things. Because this is our train model. Output is empty for now. So nothing to see. Let it train. And the step 9 will be to test our model, with our user input. So let's go to our step 9. We have saved our model. We have saved our tokenizer in step 8. And in step 9, we are actually using our model to respond to our query. So we'll say from transformers import something called pipeline, and then pipe is equals to pipeline and text generation. Model is equals to model tokenizer is equals to tokenizer, isn't it? Tokenizer is equals to tokenizer that we have saved. Nothing wrong with it. And then comes a prompt that we'll prompt to our own model that we might have trained. Prompt, well, it's taking too much time. It's taking, well, cannot expect something less. That's why big companies are using GPUs and whatnot. Okay, so prompt is that user is saying something like how to list files in Linux. So I think this is something we have trained on. Linux backslash n, and then assistant would go like whatever the assistant is. How to list files in Linux. Why did we use this assistant? I don't know. I have no idea. Nope. No idea. Prompt is there. Result. Try and prompt max new tokens is 100. Well, we'll make it 50. And we'll print result as an array that is 0th position, and whatever the generated text is, generated text. Important notice is that, well, read this. First run will be slow. That is this, I guess. If memory error, like, if we get a memory error, RAM related to RAM, I guess, We should reduce our max length, which is where, which is somewhere we've defined max. Yeah, over here. We should make it 256, but we didn't get any error while tokenizing the dataset. And data set size matters because small data set is noticeable but limited improvement. Still great for learning, so we can just increase the epoch for training. That, but we shouldn't increase it too much so that it'll only know about data set. It'll start parroting our data set. We don't want it to parrot, but we want it to learn from it. Okay, batch size, that is 1. Batch size is 2 right now, I guess. I wrote it somewhere. Yeah, batch size is 2, isn't it? Data size matters. You know what you just built. Your own fine-tuned model, trained your own data set, running on Collab. This is literally how real AI system starts. Okay. But we didn't start from, base up, but we took a really small model and improved it based on our data set that we had of about 180, lines. So we tokenized it, we gave it to a model, and now that will give something as an output. This is what we did, to improve our step 4, which was giving us errors. Replace step 4 with this. This works, important note, and all that. Okay. So I think I'll also, create something called, what should I call it? Conversation. Let's call it conversation. Make directory, and we'll make a directory of conversation. All right. We'll go into that and we'll start naming it as 1, 2, 3 or whatever. So it's empty. We'll create a 1.md and we will copy paste the whole damn conversation from here so that you can refer to this conversation from my GitHub repo. That will be posted, I guess. Let's post it. Yep. Also edit our, readme. Anchor tag. We give us anchor tag. That is a href. What was conversation? one.md. And we'll say 1.md. I hope this will work. And let's, push it. So we'll say something like git add, git commit. While committing, we'll say conversation. So we'll say conv and we'll push it at the end. Yep. Yep. So we have a conversation. And if we go to 1.md, oh, conversation. We have 1.md, so why is it creating an error? Conversation. Did I do something? Did I make a mistake while writing HTML? Or is it a spelling mistake? Conver, Sation. Oh shit. Where is this T coming from? X. Conversation. Isn't it? So it was not HTML mistake, but as usual, my spelling mistake. I hate it, but I cannot avoid it. So let's embrace it and hope that it works out for us. 1.md. Shit. Oh, so it must take some time to load. Let's load it properly. Oh, whoa, whoa, whoa. Step 7 gave us an error. What is the error? Value error. That model did not return a loss from the input. Only the following key, that is logits. For reference, the input it received are output IDs. Oh shit. So, well, let's first of all, So yeah, 1.md works for now. And I'll make it, public at a link, I guess, using GitHub pages. Let's do that first of all. Settings, GitHub pages. Where are you? Pages. And deploy from branch. Yeah, exactly. No actions. The branch is called main. Save it. And it will start probably deploying it. Yeah, so it's deploying it. Till then, let's go back to our conversation. Let's give it a reference that we performed the step 5 as it said earlier. So we did step 4. It's running well. Let's give it the code for step 4. Or should we directly give it the output? Directly give it the output. We did the step 5 as well. That is this. And the output that we got was this. Also, step 6, that is this. And the output that we got was this, that it mapped it. So correct output. But not nut, but a but. But at shit, did I press enter? Oh, whoa. Did I press enter? Well, it seems I did. Perfect. You are in really good spot now. Everything you've done so far is correct and stable. What you've done is sanity check for step 4. There is no errors. Good. Step 5, that is LoRa applied. We have trainable person, that is 0.0942. And this is exactly what you want. We want it approximate about 0.1% parameter train. Efficient for fine tuning and for Triton warning that we got is it Triton or is it something else? Warning that detected no Triton, ignored it for now, so not required for your training, only affects some optimizations. Okay. And step 6, that is tokenization, works well. Here's a small improvement. Fix before step 7, that is very important. Right now, your dataset only has input IDs, attention, but training needs label. So update this. Step 6. What is getting updated? Let me see. So we will tokenize, and we made a variable called tokens, and we are returning the same thing, that is tokenizer, example text, truncation is true, padding is blah blah blah, and we are returning this token. That's what I expected. But we are also making label for it, that is input ID copy. All right, and at the end we are making the same damn thing. Nothing much, just one line has been added and the return type has been changed. We are returning a variable that is assigned the value of what the return type earlier was. Nothing changed except for this. Let's run it. No problem. Oh, there is a problem. What did I do? Why? Yeah. The step 6 comment should remain there. I'll also download this, Jupyter notebook and upload it. What should I name it? Train. Train what? Train AI model 1. So this is the first block of code. We ran it. Let's run it again. It'll probably take time, but we have time. We have lots of time. We fixed it. Step 7, it says do this. That is exactly the same. Batch size 2, this 3, this 10, 50. Report to none. Okay. Trainer is this. Trainer.train. And that's it. If you get errors here, CUDA or memory error, I have 16 error. What to expect? Loss is decreasing where I don't see a loss. We hope to see a loss, but that's why we get errors earlier as well. But at step 7, let's paste our code. That is for our step 7. I expect to give some error. That's what I expect. And I'll say output is this. Well, give us output. It will not give us very quickly. So let's set up a C setup for our. Yeah. So it has been deployed. GitHub pages. So what is the link? Well, MIDI 870 train models. That's exactly what the link is. That's what I hope. Yeah. So it's this is the link. If you can see it. And from here, you can open it up in your browser. Exactly like this. Doesn't look that bad. Sometimes it does. So earlier we got a memory error, that is RAM error. So I thought, why not just reduce it from 512 to 256? But I said, let's try again because we saw some sort of different error. But right now we are seeing a very different error, that model is not equal to model. So what is the model? Uh, I guess model name or something else. So let's just copy this. That is name error, isn't it? And pass that as an output. We got this, and we also got memory error. The whole session actually crashed. That's not a big issue for now. This means the runtime lost the model variable, or the step 4 out of 5 cells wasn't executed in the cell. What? No way. Uh, let's start from here, 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 this one, then this one, step 5 as well, and step 6, and now step 7. So it is at step 4 where we are, I guess, tokenizing it, 34%. Okay. You ran out of cell out of order. Your cell ran out of order. So runtime restarted silently. So kernel reset after installation. Yeah. So this whole collab thing actually crashed. So that's why. Yeah, we restarted. So show the diff. What is the difference? Okay, save these changes here. Now we are at step 7 and we should see some real errors. Some real errors, not this. No need. We just ran our all other steps. And let's expect for an error. I'm thinking of making another series where we'll actually, well, train a model in different ways, different formats, different models. Uh, we'll make our own RAG and finally our agentic AI. Well, I was working on agentic AI, so till it's running, I'll show you. So I was working on agentic AI here. So I made quite a progress, and well, this is all because of mostly GPT, but GPT also hallucinates. So either hallucinates or the information has updated and it hasn't updated its information. So yeah, I had to use Olama docs to get out of certain errors. Very interesting. We'll actually format it properly and make this somewhat human readable, because right now it's only me who can understand it. So yeah, why not just make our own model, create our own RAG for more context, and well, create our own agents to work. I was also working on File Explorer, that is, so that we can manipulate everything using Python. That we can do But I want to rethink the whole thing so that we can, give the whole control, most of the control, a limited control of certain directories as a root directory. It can't go behind that directory, and that whole control to this AI agent that we might have created. That was my thinking. That one. Well, it has been nearly about 20 minutes and still training. I'll probably I'll probably cut this portion or make it speed up because it is taking a lot. It has been 36 minutes or about 40 minutes now. That's, well, not even stopping, not even taking a break. And the RAM is C, it's filled. So either it'll probably crash or, well, we'll get a model. Hello? Yeah. So it has nearly taken like 1 hour and 28 minutes. And so I got confused. Like there are only 180 data points and it shouldn't take this much of a time. So yeah, so I asked it and it says if you see something like loss and all these things, loss, epoch, and max length, then you can go for it. Otherwise, well, stop it. So I said I am only seeing this thing, which is user local pi and whatever, the address of the initialization. So yeah, it said, yeah, interrupt it right now. You're not training, you're basically running on CPU with no progress logs. So what's happening is, this is the warning that pin memory argument is set to true, but no accelerator is found. So no GPU is being used. Training is on CPU. That's why super slow, no visible progress, looks stuck. Why there is no log is because by default trainer logs every logging step, but CPU plus slow batch takes forever to reach even step 10. Enable GPU. So like I have to reconnect, but through a different runtime. So we'll change the runtime to instead of CPU to GPU, right? And to verify GPU, we'll do this step. That is to verify our GPU. Come up over here. This is our comment. We'll say import torch and we'll print torch dot CUDA is available. Available. Yep. So it's allocating runtime right now. Yeah, runtime has been allocated. Let's see. It says unable to connect to runtime. Damn. So it says reloaded. So we reload it properly. Internet is connected. So I think the whole thing has crashed. So let's open up properly. Internet is there. It's a bit slow, but yeah, it is there. And we were train models, isn't it? Now we'll connect a runtime which has a GPU. And we'll verify if there is a GPU or not. So now again, what we'll say is change the runtime to not TPU but GPU. Save it. Reconnect. Unable to connect to the runtime. I guess I might have consumed. No, it got connected. Shit. Yeah, because I was running for I don't know how many minutes, so I thought I just consume the free tier access that we get. So we'll verify GPU first. Oh, not this. This. Let's run it. Yeah, so GPU is available. We got it true. Uh, let's run this git clone as well. Shall we just try using git clone like this? Yeah, so this also cloned. Where did it clone? Let's see. ls. Yeah, so train model is there. Nicely done. So we'll run this. After that, we'll install from pip. We'll load our dataset after that. Yep. Then we'll say model name. So model name is phi2. It is there. Yeah, it was a variable. So nothing to process. Now step 3 was to format the dataset. So it has formatted. And now step 4 was to load tokenizer and model both. This will take a little bit of time. A little bit of time. After that, we'll do the sanity check that everything is working good. And then step 5, that is to apply the LoRa. And this is the magic. Right. We'll also change something like max length and all that. Where's this max length? Max length, where are you? Number of epoch. Mhm, mhm. Max length from 512 to 256. Okay. We should add this as training arguments. Where is the training arguments? Content output. So this ran our step 4 and sanity check is done. Step 5 is done, I guess. Yeah. Now this is our tokenized data set. Let's tokenize it. It's done. And this is training. And we should see something like report to. Yeah. So I was saying we should see something like logs where we see the loss and all that. Uh, Otherwise, again, some sort of problem. And let's run it. I hope it works this time. I start seeing logs quickly. Yeah. So we are seeing something that is, yeah, step is 10. And over here also we are seeing 270 steps. And at each step we are seeing the training loss that is reducing, and it should reduce as much as possible. Because, yeah, it has reduced in 30 steps only. It's good. It's working. It's nice. Nicely done. Now our step 7 is actually working. I don't know, it is because of runtime change. I hope it is because of the runtime change. And so if anyone will thought of running it locally, if you have a GPU, you're good to go. If you don't have a GPU, well, don't take the risk of, wasting your compute. Just go to Google Colab and, spend a little bit of internet after, you know, making the training possible and everything. And it'll save the model. So just download it from there. So it has reached the half step. Our loss is still significant, but reducing. Now it's not. It was reducing up to 120 steps, and after that, it didn't reduce for 150 steps, and 160 it reduced, and 170, well, it's fluctuating. So I think there is some sort of problem that I should address to. See, it's fluctuating. It's diverging and converging back. See, what is the issue? 270 steps, no? So 50 steps remaining, 40 steps, 30 steps, 20 steps, 10 steps. Well, it's done. And well, before saving the model, we'll say we'll copy this output and say it's a thing instead of converging after a point. POINT. Oh, fluctuating spelling was wrong. Yeah, this is actually good news, not a problem. What you're seeing is The loss first of all reduced, and then it was fluctuating near 0.1. And this is normal training behavior. I didn't expect this sort of training behavior because when I was training on, uh, the simulated data, it was near perfect, near perfect. But it says this is normal, so we'll take it as normal. And then after initial learning, more quickly learn basic, loss drops fast, then matches up. Different data is small, so when I samples, gradient varies, so loss oscillates slightly. What matters is look at the trend. That is 11 to 0. Okay, so we have reduced the length, max length. So let's reset it to 512 and let's see what happens. Yeah, it has taken the length of 512. Let's see what it does. Now it's going a little bit slowly because the length is a little big, isn't it? Now we have completed our 10 in C. In the 10th step, see the loss. It's damn good. This is impressive. I'll report that as well. So I'll say after changing CHA. Array, yeah. After changing the max length back to 512, loss merges from before. Why? Let's also, clarify some of the theories. Like, why did it do something so absurd? And now it's near fluctuating over there only. So 0.05, 0.06, 0.04. Yeah, that's acceptable. This is our progress and it will take around 2 minutes. And I'd also like to see after increasing the learning rate, how much can we increase the learning rate? One hundred steps remaining. Nice. Why have we declared that we need 270 steps only? I want to see that. Where have we declared this? 270 steps. Mm-hmm. I don't know how this 270 steps is the number. All right. Now, this is something that is very familiar to us, isn't it? Last 20 steps. So it is trained, and let's give this data back. We perform the step 8, so it has saved it. Step 9, we will give it a prompt and we'll expect some output, that is use ls to list files in the current directory. Nice. How to list file in Linux, and we got a response. That is this. Nicely done. What if I make a mistake? Instead of list, I say lsit. Will it understand? Hmm. It does understand it. Nicely done. What about now? Like real typing mistakes that happens. Ah, now it doesn't. Now it doesn't understand what this LIDST means. So don't make a lot of typing mistake, because, well, models like this will get confused. Like, what are you actually expecting? So don't make spelling mistakes while you are playing with local small models. All right. Linux. How about Windows or PowerShell? I hope it doesn't have, you know, the context about this, so it'll probably hallucinate or something like that. Yeah, so it hallucinates something like use print objects and list. Does this work in PowerShell? I don't know. I don't use PowerShell, so is this good? Is this bad? Or did it just hallucinate? Um, I'm liking this. I am liking this. Also, let's see the file explorer of what we see in the output directory that we might have created. Yep, over here. So this is, checkpoint. For every checkpoint, we might have some. Hmm, nice. Safe tensors, JSON, and PT, PTH, PT. I think these are pointers or vectors. Binary, JSON. Will we be understand this JSON? Will we be able to understand what the JSON says? Best global step, null, best matrix, whatever, epoch, learning state. Okay, we understand it, but what is the use of this? And who is creating this? Is this our library that is creating it? Because, yeah, we didn't write something like this. All right, so we see certain checkpoints at every 50 steps, and at the end, nothing different, same things. And this is a big file. Yep, that's why it's taking time to even load and open them. We'll not do something stupid, but we already have done this, so I don't know. So the reasoning behind, why our loss rates was so low after increasing the length, max length, is because we gave the model more context, which is, easier prediction, so lower loss. What changed technically was the max length, that is 256 earlier. The sequence were cut off. Model saw something like this and had to guess the missing part. Harder task, and it has higher loss. With something like 512, the full example is preserved and everything is good. Model sees the full pattern, complete structures, correct ending, much easier learning. Deeper intuition, oh, don't. We don't want to download it. Deeper intuition is, this is the key. LLM learns like predict the next token given the previous tokens is this. So the shorter context is like incomplete story. So it is hard to predict what is next. But with the full context, the complete story and predictable pattern. So while loss is nearly this because the data is small, which is 180 samples. It has a repetitive pattern that is user and assistant. Model basically memorize the pattern, learn formatting very well. Important reality check is low loss is not equal to smart model. Right now, low loss is equals to good memorization. So yeah, it has memorized our questions and the answers, standard answers to it. So this does not necessarily means it is a deep reasoning model. This is just a model that has remembered what we asked and well is giving us certain output regarding that. Just probability machine. This is a simplest probability machine predicting the next word instead of the probability. What this means for your model is we have a strong formatting learning, good response style, better output than before. Limitation is that may overfit, may fail, or on unseen queries. I don't know if this is a, let's give it a unseen query. It responded to an unseen. Why? Is it good, bad, worse? What is it? This was the prompt. No need to give the prompt because it already takes the prompt, how to list and all these things. So overfitting risk is high, very low loss, that is this. So stable outputs, but limited variation. What would I do is we'll make the 512, which is good. It'll change the epoch to 1 to 2. We have 3 epochs. It is not bad. We'll ask this question as well. Let's come up over here. Give us the question. PROMPT prompt is equals to, and we'll paste it. This is prompt, and then this will be the next prompt. PROMPT. Then we have another prompt. PT prompt. And that is all right. And what we'll do is we'll copy and paste this 3 times and hope that it works. Otherwise, we might have to copy and paste everything, and that too separately. Run it. How to fix API error? It says this is the response. User asked write Python function for factorial and it wrote this function. And user said explain Docker in 1 line and it did this. Docker is a tool and blah blah blah. So we'll copy this. seems to have. So let's copy it. So this is a very good result for the first time, fine tuning it, but with some important caveats. Let's break it down honestly. So yeah, so first thing, it hallucinated because, you know, it doesn't mean anything. So this is a bad output. We can, in PowerShell, we do ls only. So it's same. But I don't know why it uses this. I was just confused because of this DLL. Windows use .dll. So I thought it must be some sort of, script in Windows 11 that I did not use. So I don't know. And why you never trained on PowerShell? So model tried to guess based on Linux patterns and produce a nonsense command, and this is hallucination. So I I said this is hallucination, and it is. The Docker answer is correct because it was trained on. So you trained similar examples and model generalized well, so it is good. Python factorial, very good. This is excellent because it has the correct logic, clean formatting. Generalization actually worked. And four, where is the okay? So question four was the API error. I thought this got some sort of API error, but I didn't even make an API. So yeah, but question four was API error, and this is solid, not memorized. Actual reasoning based answer is this API. Warning message is something like max token and max length set. Well, ignore this. Not a model issue. Just fix your generation call. That is this. Remove the max length, and it'll be all right. Okay, it's done. It's done. Oh, this one also. Yep. Now we won't face this issue. Oh, whoa, whoa. You still see this. I don't know why. And what this tells us about your model is blah blah blah. But what is important is I want to see whether my data set stored something like factorial in or not. So let's go, and this is important. Data. I will see whether it had something like factorial. Nope. Python code n equals to. Where is the code here? Let's set wrap so that I can see everything at once. CI/CD is there. 148. Something about database and SQL. This is about Flask. So a little bit about Flask. This is a Python program. I guess this is, what is this? For I in range to this is prime numbers. Okay. We are checking for prime numbers as well in Python. I think if we didn't train it on, factorial or something like that, It might already be trained because it's 5.2, so it's not that primitive. It's still not a very good model. In our dataset, I don't see any factorial. Oh, I do. No, I don't. It's even or odd. So nope. So we'll say something like our setup needs more fair comparison. Our setup needs more fair comparison. So we will compare first the model on the same prompt without training, and then after training and compare. How about this? What you're trying to do is normalized base model with no training versus this fine-tuned model, that is our LoRa. So this is a fair comparison. So what we'll do is step one, load the base model, no training, load your fine-tuned model and create pipeline. Test with same prompt. And what we'll look for is, all right. And you will likely observe that base model has more general knowledge, worse formatting, less aligned to your style. Whereas fine-tuned model is better structured, that is user and assistant that we are seeing over here. Nicely done. Better on your domain, worse on unseen topics, that is hallucination. So we'll copy and paste thing. We'll create a text first of all, that is called fair comparison. Nicely done. Fair comparison. All right. Then, oh, not this, but we'll actually code it. Where's the code? Step one is this, and we'll take the tokenizers base model, that is LoRa, no LoRa. Okay. This is a step two that we will load the fine-tuned model. That is this. Let's comment it out. Yep. And at the end, we will compare both the answers. Is there something called fine-tuned model? Oh, so it's a directory. And this is the final fine-tuned model that we are taking. Nice, nice. How much size is it? This will not tell us, but the terminal will. We will see that later on. Create pipeline. So it's loading a base model. It loaded. Now load a fine-tuned model. Fine model is the variable. And we are sending both of these to different, fine-tuned model and base model. Nicely done. Certain warnings. And we'll test it with the same prompt. That is this. Prompt is user how to list files in Linux, and will be passed to base model. To list files in Linux, you can use the ls command and so on. Can we wrap it? How do wrap this cell? Add no. I think we can't wrap it. Okay, so this is done. But as for fine tune model, we'll probably see what we did directly the command, that is ls. So this will be useful like when I created the pipelines where I want my AI to not just interact, like interaction model can be a general model anywhere. I want a very local model that is very specific and specialized to make, let's say, presentation in a certain format, that is JSON, which is slide 1, slide 2, slide 3, and so on, and content is stored inside like a JSON format proper. So instead of using a very high-end model that's pricey, we can just fine-tune a normal model that knows how to speak into doing stuff that we need and how we need to do it. And the training steps, uh, like just on CPU, it nearly took about 1 hour and something, and didn't give us any result. But just after using GPU, it was done in how many minutes? The training step, how much time it took? Approx 4 minutes. Nicely done. This is something we see. Why is it taking so much time? I don't know why it's taking so long. That's not how it should work. Oh, so we are loading two models that is 2.7B each. Base model and fine model that is heavy for collab GPU, so slow inference. Problem two is your fine-tuned model didn't respond yet. Most likely the GPU memory is tight. Let's see how tight. Oh, whoa, whoa, whoa. It is tight. So pipeline is slow switching model or generation is queued. Immediate fixes is remove the warning and clean generation. Do not pass the max length. Test model one by one. Important. Ah, now it gave us a output. So it was probably queued. So it took a lot of time. And it gave us a command. Okay, so it gave us an output. Let's compare. We got an output. Let's compare. So this is a very clean comparison. Honestly, you did this exactly like a proper ML evaluation. Let's break it down like an engineer. Okay, GPT stuff. Pros is that it is correct, slightly more detailed, names and size, base model. Cons is that not aligned to your format. How is it not aligned to my format? Need more verbose than needed. Fine-tuned model pros is that is clean, concise, matches your dataset style. Proper use in assistant format. Well, it also had this, so not a problem. I don't know how, but it also had this. Matches your dataset style. Proper user assistant formatting. Slightly more practical document example. I don't see a document example. Do I? Okay. So it gave us an example, but this also gave us an example. So what the hell do you want me to do? But this will work. Why? Because in Linux, document is starting with capital E. Shit. I never expected to say something like this. Well, I'm not joking, first of all, but this much of a difference is something that is, well, even username has to be changed. Like if you are, let's say, whatever the username is, you have to type it out. So both of those probably not work. And I don't see much of a difference. I just asked this how to do, hallucination control and all this. Uh, we'll do it if it's a less code. We'll skip this and conclude this video if it is not. This is a highest return on investment step that you can take right now. This is where your model goes from toy fine tune to actually useful system. Okay, known domain, that is correct. Unknown domain, it hallucinates like PowerShell command for listing. You know. So if it goes to unknown domain, so I probably heard about H nodes and all that. Can we do something like this? H node. Like if you tone down the H node, it'll probably become not more friendly, not trying to satisfy you at all. But then it'll give you a honest response. That if it doesn't know, it'll directly say it doesn't know. So it's called H node. Instead of saying I don't know, if content is how to list files in PowerShell, assistant use get child item to list files in PowerShell. I cannot assist with the request. I do not have knowledge in this area. But that's also, hard coding into a data set, something like this. So I'll probably avoid it. Since we are doing it, let's do it. No worries. Oh, we have to push it as well. Or let's add it over here as well. Where are you, dataset? Where are you? Sample data? No, this is not our data. This is our data. And let's add it. Over here. Yep, it's added. Save it. It is saved. And what we'll do is, how about, hey, how to stop this? Change the runtime from GPU to CPU. It has every file. Oh, did it lost? So it loses file every time. If I say run all, it will probably run and will get stuck at step 7. And if it gets stuck more than 4 minutes, we are going to close it. And side by side, let's see how much of a RAM and all these things it uses. First of all, it did this, then this, and our data set is gone. So why not just push it? Before doing that, let's do something interesting. That is to change our conversation1.md to its full length. Okay. Oh, not this, not this, not this. Shit. So it is at step 4, tokenizer step. Is it done? Yep, seems like it is. Okay. And what we should do is add some more to dataset. Append bit or something like this. Yep, it'll work. Copy this. Okay, this is done. Let's clear everything. Uh, let's add everything. Commit instead of con. Let's say update, and we git push everything. And let's go to the first over here. Let's see if it got updated right now. 2 hours ago. Right now, it should be updated right now. Yep, now it has been updated. So let's do the git clone again. That we get the latest data. So it is training at this. Let's stop it because it's not worthwhile. We know how it works. Everything is done. And I'll probably stop this over here. Okay. All right. So now we know how to take a model, how we can train it, and how to, generate output from it, how to compare between the base model and the fine-tuned model. So I'll probably download it and give it to you. Okay. And that's it. Every link will be in the description. So do check it out.